Hi everyone, today we'll be looking at the May 19 1H paper, the non-calculator paper. So question 1, we've got blue cubes, red cubes and yellow cubes in a box. And we've got the table showing the probability of taking at random a blue cube from the box. So that's 0.2. And now we are told that the number of red cubes is the same as the number of yellow cubes, which means that if I call this P and this P here, then 0.2 plus P should be giving an answer of 1. So 2P is equal to 0.8, leading to P being 0.4. So I will be completing the table with 0.4 for red and 0.4 for yellow. Part B, we are told that there are 12 blue cubes in the box and we need to work out the total number of cubes in the box. Now looking at the table, we see that the probability of picking a blue cube is 0.2, which is a fifth. So if 12 cubes represent a fifth of the total, and it's obvious that to go for the total, so to go to 5 over 5, I should be multiplying by 5. So I'll do the same here, and I get an answer of 60. So there must be 60 cubes in total within the box. Question 2, we've got Dion who needs 50 grams of sugar to make 15 biscuits. She also needs 3 times as much flour as sugar and 2 times as much butter as sugar. She will be making 60 biscuits and we need to work out the amount of flour she needs. Now, 50 grams for 15 biscuits, well, to make 4 times these 60 biscuits, I'll multiply by 4. So I will start by saying that I will need in total 50 grams times 4, which is 200 grams of sugar. And to find the amount of flour needed, well, it says that it's 3 times. So I'll multiply this by 3 and I get 600 grams of flour. Now she has to buy all the butter she needs to make the 60 biscuits, and she buys the butter in 250 gram packs. How many packs does she need to buy? Well, we need to concentrate on the amount of butter we need. We need twice as much butter as sugar. So we need 2 times 200. So we need 400 grams of butter. Now, given the fact that the butter is coming into 250 gram packs, we need 2 of them. Question 3, we're being asked to find the highest common factor of 72 and 90. I will start by splitting 72 into prime numbers. So 72 over 2 is 36, over 2 is 18, over 2 is 9, 3, 3, 3, 1. I keep doing this process until I hit on 1. And then for 90, I will start with 2, taking me to 45, 3 to 15, 3 to 5, 5 to 1. And we're looking for the highest common factor. I see a 2 being common, a 3 being common, and another 3 being common. So the highest common factor has to be 2 times 3 times 3, which is 18. In question 4, the diagram shows the plan, front elevation and side elevation of a solid shape drawn on a centimeter grid. So from above, it's a circle, and then from the front and the side, it's the same rectangle that measures 4 by 5. We need to draw a sketch of the solid shape, and we need to give the dimensions of the solid on the sketch. So something that when looked from above is a circle and when looked from side is a rectangle must be a cylinder. So we've got this kind of situation here. So I'm gonna quickly draw the cylinder. It looks something like this, and it should have a height of 5 centimeters because this is the height here, 5 centimeters, and the width, which will be the diameter of the cylinder, has to be 4 centimeters. So this distance here is 4 centimeters. In question 5, we are told that the shape A can be transformed to shape B by a reflection in the x-axis followed by a translation by the vector CD. We need to work out the value of C and the value of D. So I will start by performing the first transformation, which is a reflection in the x-axis. So I'm going to take A. If I reflect this along the x-axis, I should be seeing something like this. And then this needs to be translated to go to B. So I see that I go from 3 to -3. So I go 6 units to the left, so it's -6, and then 1 unit down. So the translation is by the vector -6, -1, which means that C is -6 and D is -1. In question 6, we've got a shop that's selling packs of black pens, red pens, and packs of green pens. We know that 2 pens in each pack of black pens. We've got 5 pens in each pack of red pens and 6 pens in each pack of green pens. And we've got the ratio of the number of packs sold, which is 7 to 3 to 4 for black to red to green. We know that a total of 212 pens have been sold. So we need to work out the number of green pens sold. So I think it's useful if I draw up a table here. I've got the black, the red, and the green. If I consider the packs, then it's going to be 7 to 3 to 4. And if I consider the pens, well, we know that there are 2 pens in each pack of black pens. So the ratio of pens, not the ratio of packs, will simply be these quantities here multiplied by the corresponding number of pens in each pack. So 7 times 2 is 14, 3 times 5 is 15, 4 times 6 is 24. So the first line is giving me the ratio of packs, the second line is giving me the ratio of pens. And therefore now, I'm going to proceed and say, if I add these up, 14 plus 15 plus 24, this is giving me 29 plus 24, which is 53. And I will divide 212 by 53, which turns out nicely to be 4. And therefore, for the number of green pens, I'm just going to do 24 times 4, and I get an answer of 96 green pens. In question 7, we've got 2 rectangles A, B, C, D, and PQRS, and we're being told that QR is 10 centimeters, so there it goes, and BC is equal to PQ. Now, the perimeter of ABCD is 26 centimeters, and the area of PQRS is 45 squared centimeters. So I will start with that last piece of information that I was given. If PQRS has an area of 45 squared centimeters, it means that PQ here should be 4.5 centimeters. And now, knowing that PQ and BC are the same, I can update here the diagram and say this is 4.5 centimeters. And therefore, I'm after the length of AB, which I will call X. AD is also 4.5 centimeters. And therefore, I can form an equation that says that 4.5 plus X plus 4.5 plus X is equal to 26. So 9 plus 2x is 26, leading to 2x being 17, and therefore x is 8.5. In question 8, we need to work out an estimate for the value of the square root of 63.5 times 101.7. I'm going to say that this is approximately the square root of 64 times 100 because both of these have nice square roots. Root of 64 times root of 100, which is 8 times 10, which is 80. And then in part B, 2.3 to the power of 6 is 148, correct to 3 significant figures. And we need to find the value of 0.23 to the power of 6, correct to 3SF. Now, I will start by writing 0.23 to the power of 6 as 2.3 over 10 to the power of 6. Now, this is 2.3 to the power of 6 over 10 to the power of 6. 2.3 to the power of 6 is 148, and over 10 to the power of 6 is 1,000,000. So I will be moving the decimal point 6 places to the left. 1, 2, 3, 4, 5, 6. So it's gonna be 0.000148. In part C, find the value of 5 to the minus 2. Well, I will start by consuming the negative sign by writing this as 1 over 5 squared, which is 1 over 25. In question 9, we need to work out 3.5 times 1 and 3 over 5. So I will start by expressing 3.5 as 7 over 2 and 1 and 3 over 5 as 8 over 5. Now the 2 with the 8 simplify, leaving a 4 in the numerator. And then 7 times 4 is 28 over 5, which is equal to 5 and 3 over 5. In question 10, we've got the graphs of 3y plus 2x is a half and 2y minus 3x is minus 113 over 12 drawn here. And we need to find estimates of the solutions. Well, it's the point of intersection that's giving me the solution of these simultaneous equations. So it looks like 2.3 and minus 1.3 to me. So x is 2.3 and y is minus 1.3. In 11, we've got the bus company recording the ages in years of people on coach A and people on coach B. We've got 23 people on coach A. Here are their ages in ascending order. We need to complete the table to show the information about the ages. So we start off with the median, where the median is the middle value. So what I could do is just say 23 values over 2, which is 11.5. Since this is not an integer, I round up and I take the 12th value, which if I go through the list here, I will find that the 12th value is 59. It's this one here. For the lower quartile Q1, I'm gonna do a quarter of 23. Now 4 in 20 goes 5, and then I'm left with 3/4, so this is 5.75. So again, I'm gonna round up and I'm gonna take the 6th value. So the 6th value, 1, 2, 3, 4, 5, 6. The lower quartile is 53. And then for the upper quartile, I'm gonna do 3/4 of 23, which is 17.75. I round up to the 18th value. And again, going through the list of numbers, the 18th value turns out to be 66. Now, for people on coach B, we've got the corresponding table of statistics. And we've got Richard, who claims that the people on coach A are younger than the people on coach B. We need to decide on whether Richard is correct and give a reason for our answer. So Richard is saying that people on coach A are younger. Well, if you look at the medians, 59 against 70, this seems to be indeed the case. So our answer will be yes. The median age of people on coach A is less than those on coach B. And then if we turn the page over, Richard says that the people on coach A vary more in age than the people on coach B. Now there is a mentioning of variability of dispersion here. I should be looking at the interquartile ranges. Well, if I go to the coach A, the interquartile range, the difference between Q3 and Q1 is 66 minus 53, which is 13. And for coach B, the interquartile range is 73 minus 54, which is 19. So we've got more variability in coach B because of the higher interquartile range. So what I could say here is that no, Richard is not correct, since IQR of people on coach A is less than coach B. So higher interquartile range means greater variability. In 12, we're being given three spheres. The volume of Q is 50% more than the volume of P. And then the volume of R is 50% more than the volume of Q. We need to find the volume of P as a fraction of the volume of R. So it makes sense to start by saying that to go from P to Q, I multiply by 1.5. To go from Q to R, I also multiply by 1.5. So it makes sense that to go from P to R, I multiply by 1.5 squared, which is 2.25. Now, 2.25 as a fraction is 9 over 4, which simply means that the volume of P times 9 over 4 is equal to the volume of R. We are after the volume of P as a fraction of the volume of R. So to rearrange, the volume of P is 4 over 9 times the volume of R. So this fraction that we were after is just 4 over 9. Question 13. Given that n can be any integer such that n is greater than 1, we need to prove that n squared minus n is never an odd number. So I will start by saying consider n squared minus n, where n is an integer greater than 1. Then n squared minus n is n brackets n minus 1. And I'm just going to state that this is the product of two consecutive integers. One of them is even, the other must be odd. And hence the product must be even. I'm only missing a conclusion here, i.e. n squared minus n is never an odd number. As required. In In 14, we need to find the exact value of tan 30 times sine of 60, and we need to give our answer in simplest form. Now we know that tan 30 is 1 over root 3, and sine 60 is root 3 over 2. So tan 30 times sine of 60 is simply 1 over root 3 times root 3 over 2. The root 3 terms cancel out, and therefore this is just a half. In 15, we've got a solid shape. It's a cone on top of a hemisphere. The height is 10 centimeters. The diameter is 6 centimeters. We are being told that the total volume of the whole shape is k pi cubic centimeters, and we need to work out the value of k. We're also given the formula for the cone and the volume of a sphere. So I will start by equating the volume, which we know is k pi, to be equal to the volume of the hemisphere plus the volume of the cone. Now the volume of the hemisphere is a half times 4 over 3 pi, and in the place of r, the radius is gonna be 3 cubed. And for the cone, it's a third pi 3 squared times the height of 10. Now before I proceed, I will be looking for some simplifications. The 2 with the 4 leaves me a 2 in the top. 3 cubed over 3, well, 3 cubed is 27, over 3 is 9. And then 3 with 3 squared leaves me with 3. Ending up at k pi is equal to 18 pi plus 30 pi. So k pi is 48 pi, which means that k is 48. 16, we've got 3 dials on a combination lock, and we've got options 1, 2, 3, 4, 5 for each dial. And we need to work out the number of different 3-digit numbers that can be set for the combination log. Well, for each dial, I've got a total of 5 options. So the total number of combinations should be 5 times 5 times 5, which is 125. In part B, we are asked to find how many of the possible 3-digit numbers have 3 different digits. So now I don't have the option of repeating a number. So if you think about it, for the first dial, I still have 5 options. But for the second one, I'm only left with 4 of them. And then for the third one, I've got a total of 3 options. So 5 times 4 is 20, times 3 is 60. So we've got 60 possibilities here, 60 different combinations. 17, given that x squared over 2, 3x plus 5 is 1 to 2, find the possible values of x. So the first thing I will do is write this as an equation. So x squared over 3x plus 5 is equal to 1 over 2. I will cross multiply to get that 2x squared is 3x plus 5. Collect everything on the left hand side. And then I will factorize this to 2x minus 5x plus 1. Which leads to x being 5 over 2 or x being minus 1. So I was expecting more than one possible values. Because of the wording of the question, I got 2 values, 5 over 2 or minus 1. 18, we need to express root 3 plus root 12 in the form a root 3. I will start by writing root 12 as root 4 times root 3, because this gives me root 3 plus 2 root 3, which is 3 root 3. And then in part B, I need to express 1 over root 3 to the power of 7 in the form of root b over c. So 1 over root 3 to the power of 7. I can start by writing it as 1 over root 3 times 1 over root 3 to the power of 6. Now, I'm gonna leave the first over root 3 as it stands, but for the second one, we know that 1 over root 3 squared is just a third. So I can write the power of 6 as 2 times 3. Because this here will simply be a third. And then I'm going to do a third to the power of 3, which is 1 over 27 times 1 over root 3. I need to rationalize the denominator, so I'll be multiplying by root 3 over root 3. And I get in the numerator root 3. And in the denominator, it's going to be 27 times 3, which is 81. We are being given that x squared minus 6x plus 1 can be written in that form. And we need to find the value of a and the value of b. This is calling for completing the square. I always start with x squared minus 6x plus 1. So I have x, half the coefficient of x, which is 3, squared. Upon expansion, this will give me x squared minus 6x plus 9, which is the 3 squared. So I will deduct the 3 squared and then the plus 1, which was always there, which gives me x minus 3 all squared minus 9 plus 1, which is x minus 3 squared minus 8. So the value of a turns out to be 3, and the value of b turns out to be 8. Hence, write down the coordinates of the turning point. Now, one of the benefits of completing the square is it makes it really easy for someone to see the turning point of a quadratic, because the x minus a squared will always be greater than or equal to 0. So if I take away b, I easily see that the minimum will be minus 8. And this minimum is attained when the bracket is 0, and the bracket is 0 when x is 3. So once you put it in this nice form, you see that the value here is the y value, and what makes this 0 will be the corresponding x value we are after. In 20, h is inversely proportional to p, so h proportional to 1 over p, which means that h is k over p. We are told that when p is 6, h is 10. So p is 6, h is 10, means that 10 is k over 6, which makes k 60. So h is 60 over p. At the same time, we know that p is directly proportional to root t. So p proportional to root t. So p is k root t for a different value of k this time. When p is 6, t is 144. So 6 is k times root of 144. The root of 144 is 12, so 6 is 12k. So 6 over 12 is k, which makes k a half. So we now know that p is a half root t. We had to find a formula for h in terms of t. So h is 60 over p, and in the place of p, I'm going to put this. So h is 60 over a half root t. I could actually stop here because I haven't been asked to give my answer in its simplest form, or I could proceed 60 divided by a half is 60 times 2, which is 120 over root t. In 21, we've got two functions, f and g. We need to find f inverse. I start by writing y is equal to 3x minus 1. I will interchange x and y. So x is 3y minus 1. So x plus 1 over 3 is y. And this is indeed the expression for f inverse of x. Now, in part B, given that f of g of x is 2g of f of x, I need to show that 15x squared minus 12x minus 1 is 0. I will start by finding what f of g of x looks like, which is f of x squared plus 4, which is 3 times x squared plus 4 minus 1, which leads to 3x squared plus 12 minus 1, which is 3x squared plus 11. Remember that for composite functions, you always start from the inside. I first did g of x, which was x squared plus 4, and then in the place of x, in f of x, instead of putting x, I've put x squared plus 4. I'm going to do the same thing for g of f of x. So g of f of x is g of 3x minus 1. Now g is x squared plus 4, which means whatever we supply to it will be squared and the 4 added. So this will be 3x minus 1 all squared plus 4. I will write out the two brackets, expand them carefully, collect the like terms to see what we got. It's 9x squared minus 3x plus 1 plus 4, which is 9x squared minus 6x plus 5. So I'm going to go back to this expression here. F of g of x, so 3x squared plus 11, is 2 times g of f of x. I will expand the right-hand side, giving me 18x squared minus 12x plus 10. I will be collecting everything on the right-hand side, giving me 15x squared minus 12x minus 1 as required. We've got only R red counters and G green counters in a bag. We take one at random. The probability was green is 3 over 7. It's then put back in the bag. We add 2 more red counters and 3 more green counters. And we take another counter at random. And now the probability of it being green is 6 over 13. We're being asked to find the number of red and the number of green counters originally. So in order to do this question, I like to draw a table. It's originally what was happening. And then after the changes that occurred here. So we had red and green counters. And we had the total here as well. We started off with R red and G green counters. And we had a total of R plus G counters. We then added 2 more red, so we went to R plus 2, and 3 more green, G plus 3, making the total R plus G plus 5. I'm going to use the two probabilities to form equations, and then it's going to be simultaneous equations. Originally, the probability we had the green counter is 3 over 7. So G over R plus G is 3 over 7. I will cross multiply. 7G is 3R plus 3G. So 4G is equal to 3R. Now, after adding 2 red and 3 greens, the probability of picking a green counter is 6 over 13. So G plus 3, the number of green counters, over the total number of counters now, R plus G plus 5, is 6 over 13. I will cross multiply to get the second equation in R and G. Expanding leads to 13G plus 39 is 6R plus 6G plus 30. So I got that 7G is 6R minus 9. Now these are my two equations. It makes sense to multiply everything here by 2 to give me 8G is 6R, because I'm gonna revisit this one here. In the place of 6R, I'm gonna put 8G. So 7G is 8G minus 9. So 9 is equal to G. And then substituting 4 times 9 is 3R. I get 36 is 3R, which makes R 12. And therefore, we've got a total of 12 red counters and 9 green counters.